So what is fatty liver? It is an abnormal accumulation of fat in the liver. So normally when fats are synthesized, the liver delivers majority of the fat to the extrahepatic tissues. But when the extrahepatic tissues are uh, filled with uh, sufficient more than enough amounts of fat, then what happens, they will be taken back to the liver itself, and what happens, this fat will be getting deposited in the liver, which is resulting in a condition known as fatty liver. Right, again, we know that the dietary lipids will be entering into the liver through chylomicrons, and they will be delivering these TG and cholesterol esters into the liver, and from the liver it is taken by the VLDL to the other tissues, right? And VLDL, as they releases the TG, what happens, the size gets reduced to give IDL, and finally majority of the TG will be released. It will be given to the tissues, to the HDL and all, and finally they will be converted to LDL, and LDL will be delivering the remaining cholesterol esters to the tissues, peripheral tissues. That's how the lipids are being distributed equally to the extrahepatic tissues, right? And from the extrahepatic tissues, the excess of the cholesterol esters will be taken up by the HDL, and they will be taken into the liver back. And this is known as the reverse cholesterol transport. And there is a sixth category, which is the free fatty acids. So what is a free fatty acid? Free fatty acids are otherwise known as non-esterified fatty acids. They are not esterified. So they are known as free fatty acids. That is not, they are not having any esterification, not having any binding. They are remaining free, right? So these free fatty acids are synthesized as a result of the, they are formed as a result of the breakdown of the TG. When TG is broken up, it gives rise to fatty acids and glycerol. So that fatty acid thus obtained is known as the free fatty acid or the non-esterified fatty acid. So these free fatty acids are transported. Since they are fatty acid in nature, they are lipophilic, hence they cannot be easily transported. And in that case, the free fatty acids are transported with the help of albumin, not with the apoproteins, as we have already discussed. In the case of lipoproteins, the lipids, lipid proteins are having apoproteins on them, A1AC, A1A2, B, C, D, E, etc. Right? But in case of free fatty acid, the free fatty acids are transported with the help of the serum albumin, not with the apoproteins. So that's the difference between the lipoproteins and the free fatty acids, right? And the free fatty acids are entering into the cells with the help of fatty acid binding protein, FABP. Right, and the T-half of fatty acids in plasma is only very short. It is only 1 to 2 minutes, after which they will be metabolized or they will be utilized. And free fatty acids are normally very small in quantities, but in during starvation, or in case of uncontrolled diabetes, the free fatty acid value can go very high because the TG is continuously getting broken up. They are subjected for catabolism, right? So in that case only, the free fatty acid levels are found to be in a very high state. Otherwise, in well-fed condition, when a person is having healthy food habits, if he is having the food habits in a normal routine, the free fatty acid level is found to be very low, right, in the circulation. Because our energy is met by the carbohydrate metabolism. So normally the free fatty acid levels are found to be very low in case of well-fed condition, and only during the starvation or in case of uncontrolled diabetes, then only the free fatty acid levels are found to be elevated. Okay, so in what is happening in the fatty liver? Fatty liver is nothing but the abnormal accumulation of fat, that is TG, in the liver cells, right? Usually TGs are deposited in the extrahepatic tissues. Of only very small quantities are found to be, of course, liver is one of the storage site of fat, but usually the only 4% of the total weight of the liver is occupied with the fat, right? Only the, if we know that a normal adult liver is weighing 1 kg, so of this 1,000 grams, only 4% is occupied. The 4% of the total weight is constituted by the lipids. The remaining weight are occupied by other biomolecules or other fat, I mean other cells and all. So it's having only very small quantity of lipids. Liver will be having only 4% of the total weight, of which again three-fourth of the fat is a phospholipid. Only 1/4 is occupied by the TG. That's a normal condition. But there are certain conditions where this value can go up. That is, the TG concentration in the liver can go up or it can get elevated. So that condition, it's not a normal condition, it's an abnormal condition, and this abnormal condition we call it as the fatty liver. So a fatty liver is nothing but the deposition of excess quantities of TG in the hepatocytes, and it can be due to various reasons. That is, it may be due to the increased, what can be the reason for the increased TG levels? Maybe the dietary intake of fat will be elevated, right? Or it can be increased quantities of calorie intake, carbohydrate content കൂടുതൽ കഴിച്ചു കഴിഞ്ഞാൽ, ഒരുപാട് മധുരം കഴിക്കുന്ന ആൾക്കാർക്ക് നമുക്ക് കണ്ടിട്ടില്ലേ, they will be fat, they will be obese, right? So increased consumption of calories, അതുപോലെ dietary carbohydrates, proteins, then when increased carbohydrates ഒക്കെ കഴിക്കുമ്പോൾ the excess of the glucose will be converted into fats. So these fat, they have to be stored somewhere, and one of the when the fatty acid level go up, if the adipocytes cannot store these fats, what happens? They will be returning the fats back to the liver. So that is another condition. Then fatty acid mobilization from the depots to the liver. If the mobilization, we have seen that these fats are always in a constant flux, right? The liver takes up the dietary lipids, they will be immediately distributed to the peripheral tissues, and peripheral tissues, what happens? The cholesterol esters will be taken up from the peripheral tissues to the liver back. But during the course of the journey, these cholesterol esters are again immediately released into the other VLDL, other lipoproteins, and also there will be always the fats mobilized within the body itself. So if there is any break in this free mobilization, it can also result in the deposition of TG or fat in the liver. So what are the conditions? The hepatic TG synthesis provides immediate stimulus for the formation of VLDL, and if there is impaired VLDL formation, what happens? The VLDL, we know that it is synthesized from the liver. So if there is any impairment in the VLDL synthesis, what happens? The TG will be remaining there. Then high carbohydrate diet, high fat consumption, then starvation, uncontrolled diabetes. So all these things can result in fatty liver. Then defective VLDL synthesis, a block in the apolipoprotein synthesis. That is, VLDL is actually made up of TGs and ApoB100, ApoC, ApoE, etc., especially ApoB100, right? So if there is any break in the synthesis, if there is any defect in the synthesis of the apoproteins, the VLDL cannot be formed. So what happens? The TG will be remaining there. So all these conditions can lead to the fatty liver. Again, the failure in the provision of phospholipids that are found in the lipoproteins, deficiency of choline. Choline, it's a lipotropic factor. Choline is a compound actually synthesized from the proteins. When we come across the amino acid metabolism, we come across this choline, right? So the choline is a very important compound which prevents the fatty liver formation. So it is known as lipotropic factors. Those compounds which prevents the body from fatty liver formation is known as lipotropic factors. So example for lipotropic factors are choline, then phosphatidylcholine, that is R-lecithin, then glycerophospholipids, then the vitamin E, selenium, all of them are lipotropic factors, or methionine. Yeah, so all these can, if there is any defect in the synthesis of the lipotropic factors, it can also result in the development of fatty liver and impaired glycosylation, impaired secretion of VLDL. There are various factors for the formation of fatty liver. That is, one is the increased synthesis of TG, and this increased synthesis of TG can be due to high carbohydrate diet, high fat, starvation, or diabetes. Now, another reason for the fatty liver is defective development of VLDL or defective synthesis of VLDL. And VLDL synthesis can go defective when there is, it can in turn be due to VLDL synthesis can become defective due to other reasons, like apoprotein synthesis is impaired, or there is the defect in the lipotropic factors. Lipotropic factors defect, impaired glycosylation, that is orotic acid. Will come across in the protein metabolism, orotic acid and all. So it impairs with the glycosylation of the lipoproteins, thereby increasing their formation of fatty liver. Then impaired maybe VLDL synthesis will be happening in the normal manner, but the release will be defective, maybe due to some oxidative stress and all, or if there is any defect in the membranes. So the secretion will be impaired. So in those cases also, the condition can become. That is, there will be increased accumulation of TG. So that is one reason for fatty liver formation, that is the TG accumulation. Another thing is alcoholic fatty liver, that is consumption of alcohol. So if there is excess intake of alcohol, what happens? Whenever a thing is consumed, what it will be subject for metabolism. In case of alcoholic fatty liver, or when a person is consuming alcohol, what happens? Alcohol undergoes metabolism. So when alcohol is undergoing metabolism, it leads to acetaldehyde formation. That is, alcohol will be converted into aldehyde, acetaldehyde, and acetone and all. So what happens? NADH, there will be this alcohol is undergoing oxidation. So alcohol oxidizing, the protons has to be released. So there will be increased quantities of NADH formation. These NADH has to be converted back into NAD, but due to the we are consuming more and more quantities of alcohol. As a result of this, there will be increased level of there will be excess quantities of NADH formation. So this NADH cannot be managed by the TCA cycle. So what happens? This NADH will be immediately undergoing oxidation, so that the oxaloacetate is taking up the NADH molecule. Oxaloacetate is present in the TCA cycle. So the TCA cycle becomes impaired. TCA cycle break varum. Karanam TCA cycle oxaloacetate continue cheyanayinu pagaram. That is, instead of the continuity of the TCA cycle, this oxaloacetate will be undergoing reduction due to the accumulation of NADH. So that malate will be formed. So the TCA cycle is impaired there, right? So what happens? The liver will be losing its capacity to carry out the oxidation. Electron transport chain will be disturbed, as a result of which what happens? The fat will be getting accumulated. So the cell will be, we know that what's the structure of a cell. Cell is having large quantity of cytoplasm, and there's at a point we'll be having the nucleus. But when there is excess consumption of fat, this fat infiltrates into the cell, and the cytoplasm will be laden with fat. Cytoplasm free a space of the cytoplasm will be acquired by the fat, so that the nucleus will be pushed towards one side, right? And finally what happens, the cell will be burst, because the fat cell will be broken up. So this condition is known as liver cirrhosis. That is the normal consistency of the cell will be lost, and the cell becomes fibrotic. So that is known as liver cirrhosis. Okay. So the fatty liver is due to the impaired fatty acid oxidation, increased lipogenesis. So NADH to NAD ratio will be increased. So as a result of which oxaloacetate TCA cycle is impaired, the cell will be losing its normal consistency and becomes fibrotic. And the condition, fibrotic means dead. Cell is dead. Cell, we can see the cell there, but it is not having the normal life. So such a cell we call it as fibrotic cell. We know that liver is the largest organ, so all the cells becomes fibrotic. So dead organ, the liver actually becomes dead. That condition is known as cirrhosis or liver cirrhosis. Okay, so these are the various types of various reasons for the development of fatty liver. Maybe due to the excess accumulation of TG, which can be due to other factors like VLDL synthesis block, secretion block, right? Different factors are lipotropic factors deficiency ഉണ്ടായിരിക്കാം, അല്ലെങ്കിൽ there will be alcoholic consumption. Again, the fatty liver can be due to another reason, which is known as non-alcoholic fatty liver. Non-alcoholic fatty liver and FLD NAFLD, that is non-alcoholic fatty liver disease. So non-alcoholic fatty liver disease, it is again another reason for the liver cirrhosis, where fat is accumulated due to high fat diet or uncontrolled diabetes. So it is not due to the alcoholism the cells are getting fibrotic. It is due to the excess consumption of fat. Okay, so based on the various reasons, the fatty liver can be divided into 5 different types. So type 1, 2, 3, 4 and 5. The type 1 is due to overfeeding of fat. Type 2 is due to oversynthesis of fat from carbohydrates. Type 3, which is also known as physiological fatty liver. It's not as physiological. It's a normal thing. That is, it may be due to excessive mobilization of fatty acids from the peripheral tissues to the liver. That is physiological fatty liver. Then type 4 is the pathological fatty liver, due to overmobilization from liver to the depots. That is, arises due to absolute or relative deficiency of VLDL, right? Then the type 5, it is due to the deficiency of coenzyme A, right? Fatty acid coenzyme A. CoA.